to the channel. I love how easily that starts up. That's brilliant. And we're going to throw the battery on. We're going to just turn this whole thing on real quick. You're going to just flip the switch.
Yep.
Alright. Perfect. Alright, and we'll just, that'll send some juice constantly into the battery right here. And this is constantly juicing our little pulse motor over here. As you can see, the numericals are going up. Might take a minute.
Come on. I'll come back to you.
Alright. Okay. So I'm going to slow up. We're going to mellow it out a little bit. We're going to stretch things out. I'm going to explain the circuit here if we, I want to, I'll show my latest addition to the circuit. We have a 1/4-inch aluminum disc. It's 6 inches in diameter. 1/4-inch thick. And we're going to place it right on the top here. And voila. It's going to start spinning really fast. So cool. So, I mean, what can we do with that? What is the purpose of having a spinning aluminum disc on the top? Well, let's see what we can get off of this light real quick. Let's make sure we're all plugged in. I can feel it moving around in there, but is it not? Let's see if the magnets will make it start up. There we go. See if I'm just trying to see if I like put it on the edge, if we get that thickness involved. But hey, the magnets make it work for sure. So we'll get the light up. So neat. See, now what you do is you take the light off of your dynamo. That's what this is, dynamo. So you take your light off, and you shove, I don't know, I want to say a 20 gauge wire down the middle, and then you clip the outside. So you got both your connections, and then you can get a reading off of this. How much DC or whatever you're getting off of it, AC.
Welcome in, KD.
Welcome. Alright, so I'm going to remove the aluminum disc for right now. Alright, that's sweet.
Yeah.
Alright, so let me break it down coil at a time. We're going to go how they're connected, okay? So we got our pace coil, which we have 12 volts going in, and it's connected in series with this coil over here. So it's wrapped around it like this. And that's how the energy flows, like so. Then the output, which is this red clip right here, the output is connected to this battery right here. So we're not wasting any energy. The energy is being stored in this battery. And I wager it's about 12.6. So it's getting up there, so it's charging a lot slower. So yeah, that's this system right here, or this coil. and then I just tied it in series with this one. So these two coils are one coil, basically. And then I've got this coil hooked up to this transistor, and it's hooked up to this battery. And the pace coils keep it moving at a certain pace. And then this coil's got 12 volts that's being forced through it by that pace. 12 volts will not run this coil on its own. You need like 24 volts.
24 volts, so you need more than one power supply if it's only a 12 volt or a power supply that can do that much.
Yeah, you need a battery that can do more than 12 volts.
Got it.
Or a power supply that can do more than 12 volts. Either way, putting 12 volts in here and trying to run it like it's running now, it won't work. It's too long, it's too big, and the wire is too small, too thin. The gauge is 26, so it won't work like that. You need a pace coil. You need something forcing the wheel to continue to move at a certain rate. And that's what we got in the first coil. Second coil, like I said, we got it forcing 12 volts through. So it actually spends very little on the battery, and it fills the cap bank up. It's like at almost 11 volts now.
I should really get there.
It does it very slowly.
Yeah, we're at 10:62 when we started.
Yeah.
7 minutes ago.
So the spend rate over here is very low. And I think it's because of the duty cycle on my switch. So the energy goes from that fat coil down to this cap bank right here. And then this cap bank with the two connections feeds this whole thing.
Oops, sorry for the finger.
So let me I might lose you. There are two drives in here. There's a 20 gauge drive and a 32 gauge drive. We got this power going into the 20 gauge, and then out of the 20 gauge it goes into this cap bank. And then the power goes into the 32 gauge, and then it goes, we don't have an out for that yet. It spends so little on the 32 gauge and it has such a big impact that I haven't clipped anything to the outside, and it all is in this cap bank. You see, what I did clip to this cap bank is the pancake coil. So the 32 gauge strand for the drive is connected to this through this cap bank, and then pancake coil is also connected to this cap bank. And we're about to, once I turn the pancake coil on, this will start to spin. Okay, this will go, the value will start to go down.
On these meters.
Yeah, even with it running. So, I mean, it does spin quite a bit. But it'll go down slowly. So, I mean, if there's any way that I can wrap this energy around and have it get back into that camp bake somehow, because apparently doing the oscillation on the pancake coil, it does produce more than you put in. So I'm going to set that up so we can see that. Alright, so we've got 3 AC volts, 3.1. That's our AC voltage going through the coil currently.
AKC, we are throwing electromagnetism around to specific inputs on a circuit, and these are pulse motors and coils and batteries
What just happened?
and cap banks.
There it is. Okay.
Yeah, that was weird. Had to be pressure on the turn.
Yeah, it's got to be a connection.
Mm-hmm.
There's our duty cycle, 50% right now on the pancake coil. All right, so let's turn on.
Right on, man. Like and subscribe.
So we got an oscillation effect already occurring without any direct power being put into it. I'm going to turn on the switch now.
Get a close up on that wave.
All right, keep it on there. Here we go. Any difference?
Yeah, it went.
No, not really. All right, all right. I got. Could you hit the
Not,
OK button?
not really. I haven't done that one yet.
All right, it's this one on the bottom.
Okay.
Hit that. Now look at it.
Ooh.
That's crazy.
So
That's 346 kilohertz in.
is that a wall? What is that?
That's the wave.
That's a wave. So it's good luck getting through that.
But if you go over here again, we are spending pretty rapidly.
And I heard that. That feels like.
That's definitely doing something different. Yeah.
Yeah. There. Oh wow. And that's out of the cat bank.
Yeah.
This one.
The big one's all connected, but
Okay, all of it. All right.
it's connected in a certain way. So yeah, it comes out the end,
There's the
but it draws from the beginning.
This is the signal generator.
All right, so I'm gonna lower that a little bit. Piezos. You can hear that. That was piezos. Look at that oscillation. It's very tight. Yeah, I don't know about that. Ooh wee, but look, I've turned that off now, right? Now look at this. It's still going. That's so cool.
Nice.
Let's turn this up. We can't have it that low, obviously. Well, we can, but it makes a lot of noise. So that's very noisy, and that's after I put the piezos on. So that's definitely got something to do with that. Probably some sort of amplification that the piezos do, but it's really loud.
That's amazing. And these are the piezos here.
Yeah. So I was just basically thinking that because, this pulse motor has two piezos on it, why not put two piezos on the solid state and see what happens? So that was awesome. That worked out rather well.
Nice. Hey everybody, welcome to the channel. Thanks for dropping in. This is Papa Bale. Like and subscribe. Let us know if you have any questions.
Heck yeah. See, the switch over there works kind of like one of these bad boys right here. I think this one will work a little bit better or faster than that one over there because of how it's built. But it's kind of the same concept. And this one is a paper clip. It doesn't need a resistor because it isn't going to break like that. It's going to break. If it breaks, it's going to break a different way.
Yeah. Just gonna get toasted by the arc.
See, and we're back to gaining on the cap bank over here because the more this value goes up, the faster the little wheel will spin. And it goes down really slowly when all this is off. when everything else is off and it's only this drawing from the cat bank, it'll go all night. It'll go all night into the next day. But you know, I mean, what's the point really? I mean, yeah, you can do that. Go all night into the next day.
Go all night.
I mean, I think even right now, if we stop it, I'm gonna stop it. And if I like remove those three, right? Now it's only one magnet, and look at how fast that is going all the way around. That is a lot more like force or thrust torque than we really need. You get what I'm saying?
Mm-hmm.
So it's like it stopped, and then just make sure that none of these other magnets are affecting it really. No. No. Bada boom. That's so cool. And that means that it's a very good rotor. But, you know, I believe that it does spend less the faster it hits, in my opinion, of what I've seen so far. So having 4 on there is going to make the amp draw go down.
Right. Which is good.
Yeah, really good. Very good.
And that's how it looks with all of them on it going. Sounds awesome.
Hell yeah, man. Smooth as silk.
Thank you for the likes, everybody.
Thanks everybody for coming in. I really appreciate it. We're just having fun here. We're going from spot to spot. It's like mini golf, kind of, right?
Right,
We're going from, we started at hole number 1.
Yeah,
We're going to hole number 2.
that's right.
This is hole number 3 right here.
Oh, man.
And like with all the rest of the holes, I can turn them on and off whenever I want. Just switch the switch on. Now the ultimate goal here is to get 2 solar panels. One to replace this power supply. Replace it with a battery and a solar panel. So the combo. And then a solar panel over there with a battery pack for it.
Right. Makes sense.
And then we'll have, you know, whatever we can get during the day charged up, and we'll have it running. Hopefully we can run and charge at the same time like we're doing here, so that we can charge the battery pack for the night and run the thing during the day with the solar panel itself. So yeah, I think that'll be great. Alright, so I believe this is a demonstration here of eddy currents. So the magnetism is gripping the aluminum basically and forcing it to spin in the direction the rotor's spinning. I think that's pretty awesome.
Yeah. Welcome to the channel, everybody. Like and subscribe if you love pulse motor content. Do it yourself, experimentations, or anything other along those lines.
Sorry, what? Yeah, just keep it quiet.
Yeah.
All right, cool. All right, here we go. A little bearing fell out. And I put that on the top here.
Before I go,
Can you please take him with you?
say hi to Tig.
Okay. Hi,
Hi,
Tiggs.
Tiggs. Okay, thank you.
Alright, come on, Tig.
And that allows the disc, the aluminum disc, to spin a little more freely, a little better. Since it is just kind of resting on that coupler right there, I decided to give it like a little more free spinability.
Yes, creates electricity. And right now we're looking at the waves it generates, but
Oh, there's nothing on that one right now.
you know we can do.
Let me, I'm just trying to balance the energy.
Mhm.
So that one's not on right now. Let me turn it on. You're still getting the oscillation effect though, which is really awesome. We were describing the repetitive uh, no, the power's not on yet. I'm just setting it
So,
up, so
great question. Why balance it? Why balance energy?
why balance the power? Because I'll spend it all because it's not looped up yet. So I'll spend it all before uh, it fills up. You gotta balance it.
So yeah, we have caps hooked in, batteries, pulse motors, piezos even,
Yep.
signal generator, 2 power supplies, and wound coils.
So 346 kilohertz is going in right now. And now I'll turn on the power.
Let me get that.
Sorry, I gotta speak up because my throat is like clogged. So I gotta speak up if I feel like I'm shouting. I'm sorry about that. All right, let's turn it on. All right, now you can get the reading.
Oop. Yeah.
I want to see what that looks like. Woo! That's pretty cool, man. And that's off the Pancake coil.
Which is here.
All right, so let me get the AC reading off of this. So it's still a 50% duty cycle. And the AC voltage is 3 volts, which makes sense. Cool. Sorry, I'm all spread all over the place. I'm on one side of the table and the other. It just, it loops around the table. So
It's a big circuit.
it's logical, but it is very large.
Mm.
I'm large. I'm a large person.
Big fingers, small clips, very small clips.
Yeah, and so it's virtually going to reflect what's comfortable for me.
I think that deserves a like.
All right, so now let's turn it off because we're spending too much now. We're down to 8 volts in the cap bank. We need to turn it around because it takes a while for it to charge, unless you're using the BEMF. Now watch that. Watch the meter, please.
Oh yeah, that's
A lot faster with it clipped on, right?
yeah. When they're getting the BEMF in there,
Yeah.
I got it, and that's all right through that junction.
Yes. It's got the Schottky diode on it. I tried using one of the little dinky diodes. I tried a mediocre diode. The fat diode is the only one that didn't burn out. So that's the one I'm using. It's a 45 amp, like 40 volt diode. So it'll handle any amp spikes that go through here.
So all of it's creating 3 volts, or what? What other numbers do we have?
Um, Yeah, I don't know exactly how to break that down. I know that Pancake coil is making 3 volts that I can put somewhere else. Um, let's move the clips around a little bit then and see what we can get.
All right.
First off, is there anything anybody wants to know? Wants me to clip up somewhere? Don't assume I know where to clip it at. I really don't know. I use a meter sparingly. Actually, I use it all the time. I just don't know if I use it correctly. So, yeah, if you got a specific reading you want, tell me where to hook it up at.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. Drop us a like, subscribe, let us know if you have any comments.
Alright, let's see here. We're going to get the end of this cap bank. So what's going into the 32 gauge strand and what's going into the pancake coil itself. Alright, so what is going on here?
Oh, it's the backing half.
No. Oh, yeah. That wasn't the reason.
Okay.
Thank you. That's good. It kind of leveled off though, where it wasn't really working that well.
Right.
But I can charge the battery, do back EMF, and all of it at the same time, so it's okay. Yeah, all this coming out of this end here should be DC. So I don't know. Oh, there you go. Ha. Yes, it is DC.
My volts. So different parts of the circuit are producing different
Amounts.
values of volt. Yeah.
And using it in different fashions.
Mhm.
So like this one right here isn't using it. The amount that's coming in from this one and being used here allows for this much to be stored in this one.
It's cool, man.
So that is very cheap to run. And look at it go, man. It's woo, yeah. That's awesome, man. The homemade switch is by far the most efficient switch I have.
Oh, welcome in.
By duty cycle.
I'm gonna need help with the pronunciation, but Hajia? Let me know.
Hello, hello. So this is a double drive, and power goes from this cap bank into the 20 gauge, and then it goes through the switch once with the 20, and then it goes through this cap bank from the 20. It's clipped right there at the end of the 20 gauge, and it goes into this cap bank, and then this cap bank spins it on a 32 gauge drive over here. So it's like, if you know how the coil's built, it's two 20 gauge strings and two 32 gauge strings. It's a dual drive bifilar. So I hooked the 2 drive coils and the 2 triggers together, and then I had to go through the 2 drives first, filter through, and then go through the 2 trigger strings. And it pounds hard, as you can see, and it's cheap, very inexpensive.
No, so low spend, Christian, not free. Low spend.
Yeah, there's no free lunches.
No free lunches.
I wish, man. I'm not trying to make free lunches either.
It's really March of Nines with low spend.
Yeah, like, give me a nickel, I'll give you a lunch.
Well, Welcome in, Gerald. Good to see you.
Welcome in, welcome in. So we got this pancake coil oscillating. And it kind of remains oscillating when I turn the signal generator off. I think that's a win. But it is running off this pulse motor's power. So it's running off of the cap bank. Um, which I think is okay. Absolutely. And with the piezos hooked up to that thing, when it starts humming at like 19,000 kilohertz, or like 19,000 hertz, 19 kilohertz, that thing starts singing and the piezos start humming too.
Yeah, over here, these ones.
It gets really loud.
There's one hanging around. Yeah.
Yeah, man, that's awesome. It's loud. It's like something that I wouldn't want to have running all night.
Directly off the cat bank, question mark?
Yeah, this cap bank right here, directly off of it. Yes.
I figured it out.
So it's the tail end of number one, number two ends right here, and then I hooked it to a pancake coil and tried to make an oscillating circuit. I think I did okay.
Yeah.
But now I can like do a Bedini, you know, throughput thing where you just connect it to the collector, and then maybe I can hook it back into this battery and like complete a loop. You know, actually do that without having it bog down and stop everything.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and you are watching Papa Bale's Pulse Motors. Like and subscribe. Let us know if you have any comments. Let us know if you're doing DIY at home.
So I'm hooking up the BEMF again. See if we can't eke some more juice out of that, because it's all starting to level off now. And it's only going to start being able to increase, you know, very slowly, incrementally now. Even with that clipped on.
And you can call me bro, Gerald. I'm Chris, bro. Or cameraman's good too. Yeah.
Yeah. So I don't know what to do with. I think we're actually getting more out of the pancake coil than we put in, by like 2 times as much literal energy.
Yeah, and he's like, spend a little, get a lot. Yay.
Yeah. This coil is a perfect example of spend a little, get a lot.
Yes.
I mean, I am spending 12 volts, but that, you know, that is kind of a lot based on what I've been doing. But it is a 12 volt system, so I don't see any wrong in that. Are you covering the...
No, it's close. It's always close. It's when I zoom in that it catches it.
Okay.
My finger was on the thing, but I moved it.
Close to being.
You can let me know if I am doing that, though, yeah.
Alright, so I'm gonna turn on this multimeter real quick. Alright, so the battery's at 12.08. It's being charged and I'm spending on it at the same time. So 12.08 is a really healthy number for how I've been using this battery. It is really healthy.
Yeah.
It's been at 12.08 for like 3 months.
Yep. Great work. Let me look at the battery. We're good.
Alright, so, oh man, I want to make some noise with that thing, but it's going to be...
Super loud.
I don't know, the piezos sound like they're going to pop.
You scaring the neighbors when I'm not here, man?
I hope not.
I'm just kidding.
I hope not. That's what it says. I hope not. See, it's going very slowly, even with the BEMF clip on right now.
Why is that?
Because it's it's like a leveling off.
At a certain fill.
Yeah.
Okay.
I think, unless something is not working properly, but it does, it goes up still, so I'm happy.
Yeah.
I think when it's down near 5 volts, you get a greater, way bigger, like faster, more volts when it's lower in the cap bank than when it's up higher in value. Why that happens, I don't know. It just does.
I was gonna sing for a minute, but I'll stop.
I don't know why it happens. Like I said, I think it's some sort of leveling off where everything kind of plateaus at around 10 volts. And all the force charging like kind of mellows down.
Because it started at
It's still going up.
9.5 when that slowed down.
I was just trying to give it a boost real quick so I could turn on the Pancake. Because you do start spending, and that value on this motor, this value is going up as well, but slowly.
And then this is
The that cap bank right there.
this one with the bright lights on it.
Yep.
Got it.
So that's what we're going to be drawing on for the Pancake coil right now when I turn it on. Alright, turning that on. Boom. Oh, we don't have any meter hooked up. We don't have a meter hooked up, so I gotta turn off the power. Only logical thing to do.
And I'll get a close up on that. Oh.
Alright, that'll work. That makes more sense than anything else. Alright,
So you have a pulse motor running a pulse motor from a cat bank.
You mean from the start, from the very beginning, it starts at the wall. Okay, it goes into the power supply, which feeds our two pace coils. Okay, and then from there, we feed 12 volts of battery into this coil. And that is forced out. This will not run on 12 volts. Okay, it's just hooked up like it's gonna run, but these two coils is what's making this thing move, not this. But all the energy is coming out of that one. You get what I'm saying? They work together to make something better. Yes. And then from where are we at? This battery and this goes to this cat bank. The output goes to this cat bank right here. Runs all this. And then from this goes to the Pancake coil, and that's where we're at right now.
Very cool.
Awesome.
How's
And I'll explain it as many times as I need to. I think it's cool. I got it down pat. So, and it's very modular. I mean, you can take away or put in anything you want wherever you want to.
Mm-hmm.
You just got to have a little bit of know-how on how it connects together and what happens.
Very nice setup. No, that is awesome.
Thank you. And I'm not necessarily one to be teaching anybody anything, but you can watch me. You can watch what I do, and when I do it right, you can try and remember that. But I don't know it like, I'm starting to get to know it like the back of my hand, but...
I'm starting to think that teaching is really going to be like that in the future. To be honest with you.
Yeah. Pick it up from observation, you mean?
Yeah, because the rest of it's going to be automated, even intelligence.
I don't care.
but the experimentation is where it happens.
Yeah, the creativity. I mean, if a robot can do it better, an AI can teach you better, let it happen.
Right, but you're not going to be really learning to do something hands-on until you do it.
Yeah, you absolutely have to get your hands
Yeah.
dirty in order to know. You don't know until you've actually done it. You've only played it, or it's like Dungeons and Dragons. Until you play it out, you've only drawn it out on paper. You know, until you actually play it out. Even with pen and paper, you have to play the game.
And yeah, teaching will be from watching experimenters, because we have the juice.
We got the juice. We know the protocol.
Yeah.
There's no protocol. I mean, just play it with it, in regards to safety. Play safe. Pretty much do whatever you want to do, and you won't get hurt.
And I'm trying to say, I think you're right. Even though you might not see yourself as a teacher, you will be teaching people.
Well, I understand people are looking at me. That's why I try. I do the best I can when I'm doing this. I love to share with people. So those who know what I'm doing, that's cool. Those who don't know what I'm doing, maybe you can pick something up and
Check out the channel, like and
Check it out.
subscribe.
uh-huh.
There's a lot of hands-on in there, and a lot of big hands with small magnets.
A lot of big magnets that go whoosh. And then you're like, ah, you need like strength. But your strength is nowhere near enough strength.
To pry it apart.
Yeah. It's like it's hopeless.
Papa Bale has already taught many.
Ah. Indeed. Well, thank you, and I appreciate that. Anybody that did pick up some stuff. That's awesome. Makes me feel pretty good that I know how to explain things in a way that people can pick up on them. All right. Yeah, it's very important to me that does happen, actually. And I'm not going to lie. That is important to me, that people understand what I'm saying. I go out of my way to try to communicate in a way that is proper. You know what I'm saying? So that not just me and my homies can understand me, but other people can understand me too. That's important to me. I do feel I always talk about bridging gaps, making a connection across something that you're not supposed to connect things across. That's called building a bridge. And I like building bridges. And that's the opposite of burning bridges, which I do occasionally.
Yeah. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. Like and subscribe. Let us know if you have any questions. Thank you.
Thank you.
I feel a sneeze coming on. Sorry.
Oh yeah. Oh man, this might be a sneeze train coming on.
Let me see if I can think of the next one
Bless you.
and keep it from coming.
Like 10 in a row, and you like bless.
He's like,
bless.
yeah, and then just be like, I'll wait, and then you think it's over.
Right, that's what I'm getting at. Bless you. Yeah. Finally. See, I mean, if you get it wrong, it's all about the bless you that you have to say. At the end, you're like, well, and that's getting it wrong. That's not what it's all about, you saying bless you. It's about the person who's dying in front of you.
Yeah.
Yeah, so it's okay.
You
You
got
don't get
it.
to say bless you. It's all right. You're not being rude. It's perfectly okay. Especially if it's like one after the other.
Oh, God. I'm sorry, all right?
No, that's cool. My bad. My bad.
At least it wasn't like Dad's. Where it's
Yeah,
just
wow.
the loudest sound ever and out of nowhere.
Oh, that's so cool.
Mm.
$9.99. $9.99 in the cat bank. 10 volts in the cat bank.
Nice.
So with each volt that increases, or each like tenth of a volt, that the wheel gets faster and faster.
That's right. This one.
All right, so we're at 10. We're gonna move the multimeter
Okay, let me get it closer.
back over to the pancake coil.
Welcome in, Ray Tech. Thanks for stopping by again.
Thank you, thank you.
Here we go. Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale's Pulse Motors, and we are working with 2 pulse motors, pancake coil, batteries,
A lot of stuff.
cat banks. Yeah. There's a lot going on here, but it's pretty cool.
It's a continuous like line so far though that I'm planning on maybe being able to plug back into itself somewhere along the line. So that once that happens, we've got our talk bubble closed loop where the wall is what's on the outside
Yeah.
and everything else is on the inside. That's what we want. That's realistic. That is, if we need to draw from the wall, we can.
Oh, 10 likes. Thank you, everybody. Thank you for the likes. We appreciate you guys.
All right, bam, we're on. Oh yeah. All right, there we go. Hey, look at that oscillation.
Oh, wow. Let me get a close up on that when you're doing that. You can see it moving. Like the tips are getting
A little farther apart.
and thicker on one side. Thank you for the like.
Oh yeah, thank you. So 333 kilohertz. Leave it at that. But what are we getting out? We're getting about 17 or 18 volts out, and we're putting in 8 right now. So we might end up either running one or the other, because right now, I'll explain it.
Alright, Papa Bale has gotten me working on my tests. I've always pondered just going solid state, but I've always liked seeing something spin. What do you guys think?
I think a healthy combination of both is probably going to win for the win. You know, I think solid state is awesome, but I also think that, you know, the rotor has its place. But maybe not as many rotors as I've got going here. Maybe just one, and then a solid state, and then back into the rotor, like a oscillator that you can obviously see that it's working. Nobody can tell you that it isn't working because you got something moving. I mean, there's a lot of things that people would say to debunk stuff, but I mean that stuff is so much more work than just actually doing it. It's like, what are you even talking about, man? Just do it. It's funny. And that's probably not what we're discussing, but I think it's great.
Hey everybody, welcome to the channel. Thanks for dropping in. Like and
It's
subscribe.
slowed down considerably.
Let us know if you have any questions. Yeah, it did.
All right, let's go over there and take a look at the meter then. It did slow down. That's awesome. Oh, that's because it's off. And this is off too, I bet. Oh.
You are like Nike, Papa Bale. Just do it.
Just do it. And like that one guy in Waterboy, you can do it.
Yeah, just set up a live.
Oh yeah, listen to that pickup speed. Woo.
Yeah, you can hear
The
that.
piezo's kicking.
What up, Mike Does?
What's up, Mike? How's it going?
Do it now. Just do it.
It done did it. Not so sure afterwards whether you should have done it or not. But before you do it, it's gung ho, man. Let's do it. Let's do it. Let's do it. And then it's like afterwards, oh man, maybe. Don't ever say maybe after the fact.
And then who is doing it? It's got to be Elena.
Yeah. Find out what Elena's doing after the show. Elena who? Which cough?
All right.
All right.
What are the I/O specs? The in-out specs. Oh, okay.
All right. On this one, it's about 11.5 volts out.
Oh yeah, we were reading that a minute ago.
Yeah, I'm not exactly sure. Well, I'll explain it like this. I'm not moving the meters around anymore because that is way too dangerous with it running. I'm not doing it. I'll explain it like this. These two coils are plugged into the wall. Okay, so I'm going to replace that connection with solar power and a battery pack. Okay, this coil is 12 volts. 12 volts are going in. But that's not how much it's drawing. It's less than 1/100 of a volt. Off the battery to fill up that cap bank. But it's all being charged simultaneously. I mean, if we're gonna figure this out, I want to know where to clip everything now. Yeah, the in and the out, but I don't know where to clip that to find it out. Everything's already linked together.
We read 2 points. There was 3 volts here and 11 volts coming out of there.
I wish I knew more on how to hook these meters up because I know that through the switch, we'll move it around a little bit. We're going to clip it to the switch, and we're going to see what's going through the switch right now. Yeah, and we'll keep the meter mobile, because we're never going to figure this out unless I move it around. I just don't want to shock myself.
Yeah, everything's plugged into the wall, man. That's been said probably a bunch, but probably before you came in.
And it'll be plugged into the sun instead of the wall when it's finished.
Yeah, the aspiration is for it to be hooked to solar panels in the windows here.
Yes, sir. Except I'm not rich, so that isn't just going to happen.
Like and subscribe. Yes. Let us know if you got any questions.
All right, through the switch. Here we go. This is how much energy is flowing through the switch currently. And it goes up as the cap bank voltage goes up.
And then I'll get a shot of the power supply.
And the differential between the cap bank amount and what's going through the switch is about 1/10 of a volt. So there's a tenth more in the cap bank than what's actually going through the switch.
Thanks, Gone404. Welcome to the channel. Appreciate the questions. And then let me get a shot of the power supply. Here we go. And that's what we're working with here. Plugged into the wall.
Now I have a Variac, but I don't know how to use it, so I'm not going to just whip it out and start plugging stuff into it.
The Variac.
I need to know how to use that before I start using it.
And how do you learn to use things other than by doing it?
If I really, really want to know something, I'll ask specific questions
Yep.
to people, and until I'm satisfied with the answer, I won't do anything.
Variable DC out from AC.
But my buddy, he got off grid basically living in an apartment using a Variac. He's got like a bill that's the bare minimum plus 7 cents.
Yep. Yep. Thanks. They are doing it.
Who's they? Is that Mike Does?
Yeah. Yeah.
Oh man. Don't troll, Mike. I'm in the bathroom.
Thank you for the like. We appreciate you guys.
You can't follow the thread, bro. No. It's okay. He's right though. Can't say they. Can't say them.
It's them.
Can't say. You know all that crap because you gotta explain who they are. You gotta say who them.
Who is they?
You don't want to know.
I've been there and I've said they, and then I get scolded for it. And I'm like, oh my goodness.
Yeah, you need a proper scolding. You're saying that they are coming back. Yes, they are coming back. That's a they are with an apostrophe in the middle. So it's they're coming back. They are coming back. They're coming back. See? And it's a they. It's definitely a they. Let's postulate on who they are, actually. And which day was it in question? We must address each day in its own context, because they are not all the same context. They. You can assume, but you know what assuming does.
Slippery slope.
Indeed.
Thank you guys for the likes.
And that's cool. I think clipping the meter to the switch shows us exactly how much energy is going through there at one point. And there are two drives going through the switch right now at one time. So that is extremely, I'd say it's, I'd say the value of this one, the big one, is the only value, it's going to be the 20 gauge strand value.
Out of this coil?
Yeah, and then I think that like the rest of it, or the little, I don't even know exactly how the energy is being drawn, but I will show you the difference. You're going to need to be closer.
Is it over 0 point? That's the question.
I don't know what 0 point is or how it works. I know that I've seen a coil that was, up like this or like that. It's not like this. It's not a radial coil, and if it is, it's like on its side or something. And I don't know, man. I'm feeling like I'll put my homemade switch up against anything. 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 Optical, anything. I'll put my homemade switch up against all of it. Now, I don't know if that's where I wanted to clip it, but we're going to find out what the rating is coming out of this cabinet.
Yeah, that prequel from like 20 years ago. That one scared me more for sure.
Alright, so the value of the big cat bank is 8.72, and the value of the little cat bank is 10.15. And so, right, I'm going to describe the flow of energy here.
Is that silver wire brushing something to switch the pulse to the cats? I think he's talking about the paperclip.
Yeah, the paperclip is the switch. This paperclip, I'll stack it up against anything.
And there's some copper there too. It's hard to see. There we go.
Alright, so here, I'm going to describe the flow of energy real quick.
Okay.
From the big coil to the cat bank, from the cat bank to the big coil to the cat bank. Oh, wait a minute, here it goes. From this cat bank to this cat bank. So it flows from that, out from there into the cat bank, from the cat bank to the 20 gauge strand, and then from the 20 gauge strand, it goes into this cat bank, and then from this cat bank, it goes into the 32 gauge strand, which, and both of those strands are hooked to the switch. So the switch is actually drawing from both cat banks when it's drawing. Right now, both of them are jetting. They're both going up. And the higher the value of this cat bank goes, of course, the higher the value this one's going to go.
Yeah, that's 6 big bangers.
Yeah, it's a 500,000 microfarad, 16.2 volt super cat bank. Hell yeah. So how are we doing? Good?
Yeah, we're at an hour.
Okay. Just,
I'm feeling all right.
alright.
I mean, I got one more of these things left, so yeah.
Okay.
So you might need to take the camera here in a minute. I mean, like in half an hour or something.
All right. So what I'm wondering, because having those two drive strands for this pulse motor separated is really good for the power output. It's good for the torque. Let me show you. Get it like a upward, downward. My bad. Downward. Yeah. Look at it. Just look at how responsive that is. That's two drives going in at the same time. So, oh yeah, I was gonna show you what they were like, not going in at the same time. All right. Okay, so that's without the 32 gauge drive, and this is with it. So it's really just a change in the piezos.
Oh yeah.
And the overall torque, because it's two different strands. So down below like that, I got mine on a little woozy. Just give me a second.
Beat is in the house.
What's up, B? How's it going? All right, let me hook up the BEMF and see if it's functioning right now.
I love the DIY switch. Don't ditch the switch. Parallel switch power. Rock and roll.
Parallel switch.
Yeah.
Yeah, I love that. I love the shirt, man. It's got that snappiness to it. Like a crisp, nicely starched ghee. That's it, ghee.
And then yeah, it breaks the sound barrier when you do it.
Yeah. Nice quick snap.
And all the windows break. Yeah.
I love that all the windows just go.
Yeah.
Mind you, the sound effects aren't coming from his mouth, so they really count. They really do.
Mm-hmm. Welcome to the channel, everybody. Thanks for dropping in. This is Papa Bale. Like and subscribe. Let us know if you have any comments.
All right. Oh, let's see what happens when I unclip this one. And then this one too. Well, it happened again. Now let's see if we can, instead of spending the energy in the 32 gauge strand, we send it all over the pancake coil. I'll be right back. But look at the energy going through that now.
Yeah.
All right, excuse me. Yeah, I'm gonna hook that back up because I need to go in there real quick.
Yep.
So that's awesome.
Yeah. You can hear that go. All right, everybody. Thank you for dropping in. Let us know if you have any questions about the build. Let us know if you have any pulse motor projects at home. We have a very knowledgeable community here and very knowledgeable people in the audience currently. So drop any questions you have. Thank you, Gerald. Have a great day. Thank you for stopping in. Appreciate you guys. Yeah, we wish. Nothing like that here, man. But you can like and subscribe. Drew. Straight up. Output. We'll get that in a minute here. Boom, 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 boom. Later, Mike. Thanks for dropping in.
See you later, Mike.
What is the amperage output?
I don't know. I don't think it matters because it's all going to be looped. So it doesn't matter. There's no real output going to be here at the end.
Because it's a closed loop.
Yeah. But I'll measure it for you.
Yeah, we'll get a reading on it in the current state.
All right, this is the current output going into the pancake coil. Is 11 volts. Now, we'll hook it to the end of the other cat bank real quick. Okay, there's 9.56 volts coming in.
You said amperage is important for charging batteries.
The batteries are charging. That's all I can tell you.
Okay.
All right, so you can't even really get an amp reading off of the cat banks.
Right.
Well, almost 200 milliamps, 177.
All right.
All right. So that's going in to the pulse motor.
Welcome in, Rosemary. Thank you for dropping by.
So let's get that same reading off this one again. All right, this one's got more, 215 milliamps, and that's probably going to increase as the capacitance fills up.
Do you think you can get to 1 amp?
1 amp off of this? No.
Okay.
Off of any of this. In this entire room, I don't think I can get 1 amp.
Thanks for the comment. Appreciate you.
No, I could be wrong. That's just what I think. I don't think I have a coil designed to generate an amp anywhere in this room. That's just what I think. I mean, I might be totally wrong about that. But this is working on stored capacitance. Okay, this isn't like a fluid. There's no load on this. Let's turn it on though and see what the load would be. Right here, that's cool. Just look at this.
Went
Oh,
down by
nice.
0.025.
Yeah, that's actually really good. That's with a
0.035.
load.
Nice.
That's actually really, really good. Yeah.
great idea to add solar. I put a diode from the plus of the panel towards the circuit so it doesn't discharge at night.
Okay.
And what was the load?
The load is the pancake coil.
This guy. Oh, it went down to 153 now.
Yeah, I just turned on the
Signal
pulse.
generator?
Yeah.
Okay.
All right, let me turn on.
Okay. What WTF is a pancake coil?
It's a flat. It's a flat coil. I believe Tesla has a patent on this. It's not Tesla's coil. His coil would be a lot bigger than this one. And it's virtually a bifilar flat ass coil.
Kimo? No. Low spend energy here. Thanks.
Right here.
Thanks for the comment.
Yeah.
Nothing like that here. You can.
We don't do free. We don't do free.
You
gotta
can like
give me
and
a nickel.
subscribe though. You can
Yeah.
like and subscribe.
Give me a nickel. It's cool. Give me $2. Inflation.
Yeah, yeah, that's steep. If I had $2 for every time I heard that, yeah, I'd have all the money in the world.
Saved $80,000 last year.
Can you show the pancake waveform again? It's awesome.
Yeah, right here. I think that's it. No, that's not it.
Hold on.
No, it's not it.
Okay.
My bad. We're going over to the pancake again. Here we go. And now that's on, so I just did something very dangerous. Just want everybody to know that. Alright, so we'll prop this up right here. We'll go positive. Wow. No. Let me turn that off. Alright. Now, we'll turn it back on. That's a pancake coil. And I don't know, remember what it was. I think it's about 11 volts are going in. And I think we're getting about 25, 26 out.
And then it not moving is that solid state or is that
That's
just its signature?
what is it called?
You're good.
Anyway, we're 310 kilohertz in. And that is, frequency. It's not resonant frequency. It's something else. Oscillation.
There we go.
There we go. It's oscillating. I got the oscillation circuit set up. We got the capacitor between the base and the emitter. We've got the capacitor or the resistor between the base and the coil. And that should set up for some oscillation. We got 2 piezos on there. Just more wires, you know. Get these coils out of here. Alright, so we got the 2 piezos. Now let's turn this down. Let's turn this down. We're going to have some fun real quick. Alright. You ready?
Yeah. Zoom in. This is kind of loud.
That's the piezos. It's amazing.
Yeah, and you hear those sounds in the lab or by the satellites and stuff. Oh, and you said the one that was full of wall spikes.
That's probably without the piezos. You want me to take those off?
Oops. That was a quick zoom down and then back to normal. It does that automatically.
I don't know if I can recreate that right now. I might be able to. I'm not going to put much time into it though. Yeah, let me take the piezos out. Because that's what it is at the...
He's like, wow, those are some painful sounds. Sounds like the music is hurting them.
Yeah, it sounds like they don't like the music. It sounds like the music doesn't like them.
Yeah.
All right. Well, I don't know, man. I kind of like the way the wave is with the piezos on there.
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale, and you're watching Papa Bale's Pulse Motors.
Can you turn that one on?
Drop us a like and subscribe.
Thank you.
Let us know if you have any questions.
8.6.
8.62.
Nice. It's actually really good still. All right, let me get the other one then. There's a square wave.
True that.
We're back in business with that.
And then they're being generated by piezos, so it's amplified on this end too.
All right, I think we got basically the wave that he's looking for over here.
Got it.
Let me hit the auto button real quick. There it is. And that's without the piezos.
And it is earlier on the live, so you can always play it back later on or take a clip from it there.
Oh, it's going up.
Yeah, 897, 898,
It's going up, and this is on.
899.
That's awesome. That means that when I turn it up to the kilohertz, it's drawing such a little amount of energy off of that cap bank that now it'll force charge, and that's exactly where we want to be. But you know, I also think that it has to do with me unplugging. Oh, I plug it back in. We're good. We are so gold right now.
Look at that. Yeah.
That's good. That is good, and it's on. So I mean, it's on, and both of these things are on, and that's still going up, man. That is freaking awesome.
Like and subscribe.
This coil right here is doing all that work,
This guy,
all that generation work,
the blue one.
off a 12-volt battery.
Duct tape.
Duct tape, baby.
Yeah.
So neat, man. That is so neat. I can't believe that's actually happening. With the square wave form, I believe this is taking less energy than having the piezos hooked up.
Nice. Straight up, Don. Yeah. It's no joke. It's not. It's what would you call that? A work hazard. Yeah. The sound of it.
Oh, you mean the piezos on the pancake coil?
Yeah.
Terrible sound. That's like if you hear that on the work spot, you're like, oh man, something's wrong. we gotta find out what's going on because we're gonna die if we don't.
Yeah. Oh, man. Great job, guys, from Beat. The
Thanks, Pete.
piezo wave was definitely cool, worth more investigation. Appreciate y'all.
Yeah, I think if we're looking for a resonant frequency, using piezos is going to help us get there. But if we're looking for just, having a nice oscillation wave like that, we don't need them.
That's right.
But the
See if I can
piezo's
get
making into a
numbers.
sine wave.
There's the numbers.
How many volts is that?
19, 22, 23.
Does anybody know how to phase lock? So I can get solid reading? Because right now I just kind of average everything in my head because it's always changing rapidly. I think it has to do with my switch.
You're averaging the numbers in your head, and you have to remember where all these clips are.
Yeah. Yeah. And you know what? It keeps me sharp.
Yeah. Oi. OG scientist. Yeah.
So I'm thinking with the fact that only 11 or 10, I think it's only like 8 really volts are going into this right now, and the fact that we're getting 24 volts out on the oscilloscope. Let's look. Oh, so we're not getting much DC out of the coil here. Let's look at AC. No AC. It doesn't seem right at all. Why is it registering like a capacitor? I think. Oh, it's not that this time. I don't know. Could be. Anybody know why I'm not getting an AC reading off my coil? I'm thinking a faulty connection somewhere. What do you guys think?
Hey everybody, welcome to the channel. Thank you for dropping in. This is Papa Bale. We're working with pulse motors this evening. Like and subscribe. Let us know if you have any comments. Let us know if you got any DIY projects at home or if you work with pulse motors yourself.
Maybe there isn't any voltage going through it with that much kilohertz.
Thanks for stopping in, Don. Appreciate you guys.
All right, thank you. The C here. Yeah, this is on. I don't know. Interesting. We got a nice wave off of it. Nice wave on there. It's just when I switch it over to a voltage reading, there's no reading.
Thank you for the likes, guys.
So now what I'm thinking, possibly, we either go pancake coil to this, or we go this to pancake coil. Heck yeah, and then we'll have, especially if volts is what we need, if we get about 200 milliamps going into this coil. So if volts is all we're going to need, because we already have the amperage that we need, basically we don't even need 200 milliamps. We need less than that.
You think 10% less, or are you talking way
I'm
less
talking
than that?
like if we use what we get out of the pancake coil and boost it through this, we'll have enough to charge battery
All right, got it.
without a problem. And then I guess we plug it right back into that battery. And that would make our talk bubble closed loop. Because we still have the wall or the solar, whatever, it's going to be solar. So we have the solar on the outside, but it'll be closed looped to that battery. Awesome.
Yeah. Another round of experimentations. And then, we'll work with some metals probably. You got the aluminum disc.
Oh, yeah. Let me show you.
I know we've had some iron filing metals.
All right. You know how I work with the Neo cubes, right?
Mm-hmm.
I'm going to make iron filing cubes. And I'm going to use a 9-magnet rotor. And I'm going to virtually put 2 of these cubes in between 3 of the magnets filled with iron filing. And we're going to try to focus the 120 energies by replacing magnets with these iron cubes.
Mm-hmm.
That's going to be awesome.
That's going to be fun.
Yeah. And I think it will, yoke them in a way, it's going to be exciting to see what happens. I have a bunch of ideas on what will happen, but I don't know what will happen. Yeah, and the aluminum disc that my brother was describing will go right on this baby right now. I mean, there's going to be other ways we can use it, but so that's eddy currents. What do you call them? Utilized eddy currents. So they're just kind of there right now. That's sweet. And it's just spinning due to the magnetic pole on it. See, now I'm holding it steady and those magnets are moving underneath it. Lots of eddies are building up in this aluminum disc from it just being still. A lot of eddies.
Mm-hmm.
And that's a Hellback array of magnets in there. So every time a magnet passes a spot, it's a north and a south hit. And a 0 point. North, south, and the null point. They all hit. Because they're all facing up. Out, I should say, out. Because it's a radial pulse motor. So I want to do one thing here, at least. So I am going to, this is my favorite rotor now. Absolutely hands down my favorite rotor.
It looks sweet.
See, so I can literally turn it upside down. Those magnets are not glued in there. But the bottom, this is iron infused PLA.
Wow.
So those magnets are being held in there by that.
So you have to use another magnet to get it out?
Yeah.
Got it.
Yeah. At least another magnet. I've done it before, so I know it'll work.
Mm.
And then the magnets here have enough strength to penetrate the iron. So they'll lift this on the toroid, even though that's iron on the bottom of that toroid.
Yeah, because he's always had another toroid on the bottom of the rotor for maglev, and this one doesn't need it.
Perfect. Well said. Okay, we got our magnet disc.
Mm-hmm.
We got about 3 or 4 bearings in here.
Usually got to work it down the shaft and then make it bounce. Oh, that's the four of them. Okay.
It's as good as it's gonna get.
I think that's good because that's heavy.
Now just scoot it in. That baby will start on its own.
And that was to the switch back here. Like and subscribe. Let us know if you have any questions.
It's a 9 magnet rotor. It's rather awesome. It's got very powerful magnets in it. But this is the rotor. Then I'm going to put the iron in.
Mm-hmm.
So these two will be iron, these two will be iron, and these two will be iron. And then these are the neos. I think that'll be sweet. It'll do something, I guarantee it. So I do think that with the 9 magnet rotor we end up spending more. I think.
Oh, gee.
906. All right, so with the switch, the paperclip switch, you gotta factor in how many magnets are on the rotor. It's very important. How many times that switch actually hits per rotation. And it's a lot easier to measure.
I'm going outside.
Okay. How much is being spent? And right there is too much. With everything on, we're now above. We're losing, even though everything is on, and that's so the 9 magnet rotor of this size.
Too
won't
big
work.
for the circus.
Yeah. Won't work.
Circuit, not circus.
Well, it is a circus, but it's a circus with purpose.
Yes.
The same purpose of a circus.
Mm-hmm.
So this has got 4 magnets. And this one will not work without the ferrite on there. It's not close enough.
Oh, the base is too big.
And then line it up off center from the coil. Because you know the magnetic field goes like this, right? There's nothing in the middle, and it goes like this. Okay? So there's north on this side, south on that side, and it goes like this. That's how it looks. And then, so you want to line up with the magnetic field on the side of the coil. You want to line your switch up in the center of the rotor, right here. It's all got to be lined up as best you can do it, and then it'll get your max speed, your max torque. It's awesome how it's lined up on the side of the coil and not in the middle. And it's lined up that way because this switch literally has like a 15% duty cycle. If you're not lined up in the hot zone, you're going to miss it.
Generic or custom PCB?
Where?
Are you talking about this one? Yeah, we print them.
Yeah, that's PLA. PCB is anything that's PCB on this entire thing. I bought for sure.
Blue. Oh, the caps?
Yeah, I bought that.
Mm-hmm. Lower
And
table. Okay, yep. Okay, sorry about that. So generic or custom, these guys. So these are bought, so they're generic.
yeah, I didn't have them make it personal. They may be custom from when they were built, but they're definitely, I didn't make them custom.
Okay. And can you make them custom?
I'm sure if you have somebody that knows how to build them, you could make them whatever way you want.
Straight.
Straight up. I wish I could build stuff like that. I don't solder, man. I do absolutely no soldering. I have a soldering gun. I want to learn how to solder, but it's going to be,
Gonna have to get a trusty assistant.
I'm going to need all the gimmicks, man. Everything to hold shit still, you know, just to make everything work properly because I'm going to show you right here, Chris. It has nothing to do with me being scared, so button it.
Yeah, he's had tremors his whole life. Says excellent work thus far. 20 likes. Thank you guys so much. We appreciate y'all.
Hell yeah, thank you. It's really hard to do this kind of work when you shake like that. And then, you know, I want to learn how to solder. People are saying, dude, if you learn how to solder, you can get rid of all the wires, or most of them.
But just think about there's this one movie. It's called The Whole Nine Yards.
Blanche.
No, when he was doing the dental work, he's all freaking out. He's like, I'm trying to make fun, but it's not funny.
No, it's good.
Well, thanks for sticking around.
Appreciate it.
Yeah.
We do make headway here, so come back and check it out. Um,
Yeah. Yep. And he's picking up new skills every week or so, guys. It's pretty cool. We know about PCB way.
hell yeah, man! They made me an aluminum Utron.
Mm-hmm.
So cool. It's only an inch big, but it's neat.
Mm-hmm.
I want to get a nice sized aluminum Utron from them that is a little bit better crafted than the one that I previously made from them. I want to, you know, hollow out the center a little bit, maybe with, this is what I want to do, man. I want to have the Utron on the outside, and then I want to have two pyramids on the inside that the fat ends touch each other. You get it? So the inside is like a hollow pyramid that is mirrored, and the outside is those mirrored cones. That would be sweet. Even though you couldn't really see what was going on in there, you got to imagine that having that pyramid spin at that rate would be doing something. And then you put something in there that will gather static. You know? You get what I'm saying? As it spins and moves around, it'll gather static electricity.
Very interesting. Thumbs up. One of these.
Like, yeah, I was just thinking about that.
Mm-hmm.
Since this is all plastic, right? The only thing that's really going to be able to be channeled through it is static.
Mm-hmm.
So that's what we got to use since I don't have metal.
Right now, yeah.
Or, you know, I don't have metal yet. I'd love to get my hands on some nicely printed aluminum Neutrons. I mean, even copper ones would be great.
Welcome to the channel, everybody. Thank you for dropping in. This is Papa Bale. You're watching Papa Bale's Pulse Motors. Let us know if you have any questions. Like and subscribe.
Heck yeah.
Yeah, we've had copper infused
Yeah.
and iron infused go through that 3D printer.
So I got the dynamo uh, from Real Light. It's a really neat dynamo. And I was trying to run it off the aluminum disc, but it wasn't working very well. Maybe it's not going fast enough. I don't know. But it works good on the magnets, and I can run the light pretty well. I want to get my multimeter on there. Yeah, we're gonna have to redo this table
Yeah, we
sooner than
will.
I want to.
We're gonna have a nice one built. We'll get it.
Yeah, we're
Welcome
gonna.
in, Lava. Yes. Looks like electric motors. Yes. Let me get a full shot of what we're doing here. Kind of. We got a lot going on. There we go.
All right, sweet. Moving up. All right, is this?
Welcome in, Sonia.
I think it is still on. Yeah. Let's turn this back on.
Chemo, welcome. Or
Hello,
my
hello.
bad, my bad. Chemo. Excuse me. And yes, we are OG scientists. That's indeed.
Is it off? Oh yeah, it is off. Wow,
Volts.
that's different.
This is the volts building up in the cap bank.
I don't think that switch is on. Is it on? On the side of the table. Other side.
Oh. It's on the line. You want the circle?
Yeah. Go ahead. Turn the circle. Yep. Now it's off all the way. That's good. It felt like it was getting low or something. I don't know. I'm gonna have to figure out what's going on with that. Perfect. So, bottom line is, this has got one avenue going in and two avenues going out. But one of those out avenues goes back to the wheel, basically.
Right.
And the other avenue goes to the pancake coil. But like I said, it's all coming from that one big coil on the other rotor. And that's awesome. Michael Faraday was explaining, and it really hit home the way he said it. It doesn't matter how many turns or windings are in the coil. It matters how much mass is there. And I mean, in a way, turns are very subjective to the coil. Like the axle matters. There's a whole mathematical formula to figure out turns. Um, but yeah, the bigger the coil, like the more I feel like the more energy comes out the other side, but it takes a lot longer for it to do so. Especially if you're working with, say a 24 volt coil size, and you're only putting 12 volts through it. And I'm virtually forcing those 12 volts to go through that 6,000 turn coil. I'm forcing that to happen. And it works. It works wonders. It works really well. I didn't know it was going to work so good. And I mean, like having the Hellback array in the magnets, like having it go Hellback instead of out facing outward. It's not north facing out, it's north facing left. So you got a north and a south and a null zone all hitting the coil on each pass. So that's good. And it does matter a lot which north or south hits first. As to whether it's going to generate, move right. Because if you get it wrong, it's going the wrong way, it's going to cost a lot. Going the right way, it's not. You know what I'm saying? Like with the Hellback array, you spin it one way, coil does good. Spin it the other way, the coil will not do so good.
All right, we're at 1 hour and 50 minutes.
Okay, that's cool. Awesome. Thank you guys.
Hey everybody, welcome to the channel. Thank you for dropping in. Drop us a like, subscribe, let us know if you have any comments. We do have a battery. Let me read some of these. Transformer can be used like a transistor. Oh, my bad. Yeah, these were said during contact, so I'm not exactly sure where they are. Sorry about that, guys. Just add frequency. We do have a signal generator over here.
Oh yeah, we got just add frequency, no power. Just frequency, huh? No power. Well, you can't do a signal generator without putting at least 5 volts into it. You can take that off, but it's a standard default setting to have 5 volts of amplification in the signal generator. So PUM maybe. We got 336 kilohertz going in right now. If we turn it on right now.
If you ever tried a Raspberry Pi.
Is that a trick question? No, I'm
to
kidding.
make a server so it can control itself.
No, I haven't done that, but I was thinking more. Well, I got to decide which one I'm going to do. I don't have an Apple, so I'm probably not going to do Raspberry Pi.
But we can do.
Arduino.
And Raspberry Pi is open source. So
Oh, sweet.
Yeah, it works.
Right, I got that one all wrong. Forgive me. Yeah, I mean, like if it's straightforward, definitely we can hook it up to an Arduino. This is way more than a 5-volt system though, so if it's gonna blow up on me, I'm not even gonna try.
But I'm excited to see you using that skill when you master it, or when you do it for the first time, I should say.
Oh yeah, yeah. Do it for the first time.
Master. That's right. He's what would that be called?
Idiot savant.
Yeah, my bad.
Idiot savant is what it's called. Savant.
Yeah, it's pretty easy out of the box kind of stuff. Cool. We'll
Hell yeah, man.
definitely get into it because we've been talking about it for a while with Arduino.
I mean, I have one. It's not like computer setup or anything like that. I mean, it probably could be. I gotta look at it.
And I remember over 10 years ago, I was working with an Arduino on a pump system for a grow.
Alright. So let's get a reading right here.
$94.6.
Alright, let's hook up the painted rotor real quick. And I think that AI is great. I mean, it takes a load off you and allows you to be more creative. with what you're doing and not waste all that creative energy on actually doing all the building of the page yourself. I mean, it is a lot you, and you got to put at least 50% of the work effort in, but you're getting like 200% of the work effort out. Oh yeah, that started itself. And it's going the opposite direction as the other one. So let's try and figure out why that's happening. Let me get my magnet detector. And we're going to wrap it up here. This is north facing out. That's probably what the difference is. Okay, and then this is south facing out. So that's what the difference is. Ooh, it's hot.
It's hot.
Yeah. All right. So this is let's try and get one of these readings real quick. So I don't know. Let's say right around 600 divided by 8. So that's very slow. It's speeding
Yeah,
up.
it's like 77, 75. Yeah, 75.
So I'd say it's going right around 100 right now.
Okay.
Because that was before it sped up.
Mm-hmm. And then it'll continue to speed up.
For a little bit. It'll mellow out. You know, it'll level off. Probably.
That's how fast cars used to be back in the day.
Yeah.
It's true.
You know how many people died back then because of car accidents?
It just driving into snowdrifts.
I'm not saying it was nobody, but oh yeah. And then why is the middle all southed out? Oh, it's probably because of the
Oh no. Turret.
the toroid. It's north facing down, so that makes sense. All right, let's see if I can move it just a little bit closer.
Yeah, you can hear that.
Got it. Oh yeah. Because if I move it too close, it's gonna cause a scene. Oh yeah. Like here again, we're lined up. Yep, we're good. And have a nice day, ladies and gentlemen. Peace out. Really appreciate you. We're all lined up. Center of the rotor, end of the switch, and edge of the coil are all lined up for maximum synergy. Thank you very much. Peace out. Have a wonderful day. Please subscribe. Bye now.
And William, we will research that. Thank you very much. The regen. Have a great night, everybody. Like and subscribe. Thanks for dropping in.